Morning, afternoon, evening, forever you're watching. Welcome back once again to the Making Masters, a channel solely dedicated to demystifying mathematics, making complex problems look easy. Come along, what do we have today? The joint variation, to join two things together from the word join. We have been looking at variation, we've looked at direct variation, inverse variation. You can check out our video on that. Today, when we talk about joint variation occurs when a variable depends on the product of two or more other variables. For example, we can say the volume of a box depends on the length, the width, and the height of that box. So we can say that volume is jointly varies with the length, the width, and the height of the box. You can also look at another example, maybe in physics. Force jointly varies with the mass and acceleration of a body. That's an example of joint variation. Let's look at this wonderful question we have on the board. Take note, joint variation involves direct variation and more than one other variation. For example, the electric resistance R of a piece of wire with a cross section is directly proportional to the length. Look at our R, the resistance R is directly proportional to the length, which is our L. Now, it says, and this R, this electric resistance, is now at the same time inversely proportional to the square of the radius. So we say L over R square. This is the square of the radius. Now, the next thing we'll do, it says find the formula connecting these variables. Find the formula connecting resistance, length, and the radius. So what do? We remove the proportionality sign and introduce the constant of proportionality, just like we have been doing. So our R will be equals to KL over R squared. Now let's find the formula connecting them by looking for the constant. So the first set of values you are given is to be used to find the constant. So we have find the formula connecting the if a 50 mm length wire. So wherever we see R, we'll put 50. Now, so this becomes, if a 50 millimeter length of wire, okay, that's the length of the wire, of 25 millimeter radius. So our radius is 25 millimeter and our resistance is 2.5. So our resistance is 2.5. So where we see R, we put 2.5. So that's 2.5 equals our K times our length is 50 mm. 50 millimeter length of wire. So that's times 50 over our radius is where's our radius? Okay, our radius is 25 millimeter. Look at the radius. It says length of wire of 25 millimeter radius. So wherever we see radius, we put 25. But this is radius square, so that's R squared. So from there, we can calculate. So 25 times 25 will give us 625. So we have that our K, 2.5, is equals to 50K over 625. Let's divide. So we have that 50. So we can cross multiply. You can say our K is equals to 625 times 2.5 over our 50. So this becomes 625 times our 2.5. We give a 1562.5. Where we divide that by 50, we'll have 31.25. So our K, our constant there is 31.25. So the formula connecting them, this is the formula connecting them. All we just need to do is to put the value of the constant. So the formula connecting them, our A, R is equals to 31.25 L over R squared. So that's the first one. That's the formula connecting the two of them. Now the second one says find the length of the wire of the same radius. that we have a resistance of 12 ohms. So straight up, we are to find the length of this wire. This is the formula connecting them. So B, the ohms there, we can rewrite it. R equals to 31.25 times the length over R squared. So our R is 12. So wherever we see our resistance, we put 12. So that's 12 equals to 31.25 times the length of the wire, which we are asked to find, with the same radius. You know, our radius was given as 25 millimeter. So over 25 millimeter, that's 25 squared, which is, let me just put it straight up. This is 625. 625. So from here we cross multiply. So our L, that's 12 times 625, is equals to 31.25 L. Divide both sides by 31.25. 31.25. So our length will be equals to, this will cancel out. So our length will be equals to 12 times 625. That will give us 7,500 divided by 31.25. That will give us 240. So the length is 240 millimeters. All right, let's look at the second example. It says P is directly proportional to X. P is directly proportional to X and to the square of Y. So directly proportional to the X and to the square of Y. So this is our expression. So the next thing, remove the proportionality sign, introduce our constant. So it follows that our P is equals to K X Y to the power of 2. Now the next thing, it says find the value of the constant, this K, if our X is 10 and our P is 1,500. So let's make K the subject of the formula here. So our K will be equals to, divide both side by XY squared. So that becomes P over XY squared. So which is equals to, our P is 1,500 over our X, what's our X is 10. 10 times our Y is 150. So 150 to the power of 2. So let's go. This becomes 150 to the power of 2 will give us 22,500 times 10. That's 225,000. So this is 1,500 over 2,500. So 0, we cancel 0 here. So we are left with, okay, 225. Okay, that's 15 here, 1. 15 here will give us 150. So our K is equals to 1 over 150. So that's the value of our constant. Okay, let's look at the B part. So this is the A part. The value of our constant is 1 over 150. The B part, it says the relationship between X, P, X, and Y. That's just putting the value of K into this formula that we have written. So that becomes, so P is equals to 1 over 150 times X, Y to the power of 2. So this is the relationship between P, X, and Y. Okay, so the last one says if Y is increased by 20%. So we can say let the value of the new Y, let the value of the new Y, of our new Y, be equals to Y1. So this Y1, it says the value of this Y was increased by 20%. That means our Y1 is equals to 20 over 100 of the value of Y plus Y. So that's the new value of Y1. So our Y here was 150. So this becomes Y1 is equals to 20 over 100 times 150 plus 150. So this and this will go off. This and this will go off. 2 times this, that's 30, plus 150, that's 180. So the value of Y1 is 180. Now it says find the corresponding percentage increase in P. Now our P, the first value of P, so let's look at it from this place. So our P1 will be equals to 1 over 150 times our X is what's our X is 10 times 10 times the new value of Y1, the new value of Y, which is 180. That's 180 squared to the power of 2. So this and this will go off. So we have that our 180 times 180 will give us 32,400 divided by 15. That will give us, so the value of our P1 is, the new value of P1 is 2,160. Now that's not all. It says find the percentage increase. So percentage increase, the formula for percentage increase is the difference in, or the increase, let me just put that as increase, over the actual length or actual amount over actual times 100. So let's find the increase. Our increase is P1 minus P. So which is 2,160 minus, what's the value of our P before it was increased? 1,500 minus 1,500. That will give us 660. That's the increase. So our percentage increase will now be 660 over, what was the value of P before? 1,500 times 100. This and this will go off. This will give us 44. So our percentage increase is 44%. Okay, so that's that for that. We found, remember when we are asked to find the value or the relationship between the variables, find the value of the constant and plug it into the equation, and that's all. All right, let's look at this final question. It says given y varies jointly as x and z and inversely as w, it says if y equals to 24 when x is 2, z is 6 and w is 1, find the formula connecting y, z and w. So the first thing we do, our y, it varies jointly as x and z, but inversely as w. That's x times z and over w. So remove the proportion sign. So y will be equals to kxz over w. Now let's find the constant given the first set of information. So y is 24. So 24 equals our k times our x is 2 times our z is 6 over, what's our w? 1. So this is k times 2 times this, that's 12k. So that's 24 equals to 12k over 1. Anything over 1 is that number. So over 12 over 12. So our k is equals to 12, we cancel here. 12 here 1, 12 here 2. Our k is 2. So the formula connecting y, x, z and w is y equals to 2xz over w. So this is the formula connecting them. Now the b part says we should find the value of y. So this is the formula, y equals to, when x is 4, remember we just found our k is 2, so we put 2 times our x is 4, we put 4 where we have x, and our z is 3, we put 3 there, over, what's our w? 2. So 2 we cancel 2, 4 times 3, our y is 12. All right, I hope you have enjoyed today's class. We looked at joint variation, and we said that joint variation occurs when a variable depends on the product of two or more other variables. All right, just like in our usual style, before we go, here's some list of take-home fun. The first one, you can practice it at your leisure time. The first one says P varies directly as the square of Q and inversely as the square root of R. And P is 48 when Q is 4 and R is 25. The first question that follows on that, it says express P in terms of Q and R. And the second one says find Q when R is 36 and P is 24. And the last one says find R when P is 10 and Q is 6.4. The second question says the current I flowing through a conductor varies directly as the velocity V and as the cross-sectional area A of the conductor. It says for a certain conductor of cross-sectional area of 250 mm square, the current flowing is given as 5.5 amperes at 10 millimeter per second. The first thing that we are asked to find is find the equation connecting I, V, and A. The second one says find the value of the velocity when the current flowing through a conductor of cross-sectional area of 450 millimeter square is 12 amperes. If you enjoyed today's class, why not give us a like, share the video, tell your friends about the Mickey Masters, a channel solely dedicated to demystifying mathematics, making complex problems look easy. If you are yet to subscribe, please kindly hit the subscribe button, turn on the notification bell so you'll be the first to be notified when new content on the channel drops. Also, do let me know the answers of this take-home fun in the comment section. And if there's any aspect of mathematics you are struggling with, or there's something you want me to solve, put it in the comment section and I'll be there to attend to you. Till we meet again in the next class, keep practicing. Remember, mathematics is fun. Shalom.